After all the parts were loaded, all that was left to do was wait for our carbon fiber spool to arrive. It was only then that I realized a problem. I wasn't going to be able to print all these pieces in time for this webinar. We have one X7 that can handle printing every part, but none of them will fit on our smaller Mark II. Time to go back to the drawing board. I needed to cut considerable time from this job. First thing I can do is to shrink some dimensions a bit so that some parts will fit on our Mark II. Having two printers running will speed things up considerably. The Mark II's x-axis is only 0.4 inches shorter than the X7, and it has a 1.8 inch shorter z-axis. While the two-step pieces must be printed on the X7, I might be able to make some adjustments to this tool's XY dimensions, or in SolidWorks case, XZ dimensions, to make the other parts fit on the Mark II. I started by shortening the step area from 15 by 10 inches to 14 by 9 inches. Now, the two cross beams will fit on the Mark II's print bed. Problem now are those vertical risers. Currently, they are 7.63 inches tall, so they'll fit on the X7's print bed, but not the Mark II's. And to clarify, they need to print upright to avoid the risk of delaminating between the layers when weight's applied. The height of the stool is 8 inches in this configuration, which is optimal based on my research, plus shortening the risers by a couple inches does not reduce the print time enough. So what do we do? This is where off-the-shelf parts come in. Now, before I said one of my criteria was to avoid off-the-shelf hardware, but that was to join parts together. Because bolts have to run through 3D prints to mate with threads on an adjacent part, they end up imparting stiffness. I want to avoid this so we can test the true strength of 3D printed parts alone. My idea is to use 4 off-the-shelf PVC pipes, one on each corner to act as the legs needed to achieve the desired height. The PVC pipes will then be attached to the step portion of the stool through a 3D printed riser adapter. In this scenario, 3D printed parts are still bearing the full weight of the person, and we're minimizing filament usage, thereby minimizing print time. So let's modify the design with this new change. Okay, so first step of the modification was to just remove the mirror, kind of delete some of our progress, going into the riser and removing that angled section, shortening it, shortening the crossbeam as well, and this little boss extrude that mates with the riser. Then I'm adding a sketch to the bottom of the riser to add the ring section that will mate with the PVC pipe. Just adding my tangencies, adjusting my clearances, and then I'm boss extruding it downwards along with the ring bit there. And then I just adjusted the base of the ring so that it's coplanar with the bottom of the riser. Adding an axis and plane so I can just add a dome section. It's more for aesthetic purposes. Nice little transition. And revolving that. And then I go about and combine that ring portion with the riser body. Doing a little cut extrude, again, just for aesthetic purposes. Splitting that body, mirroring it, mirroring the new crossbeam, and then combining the crossbeam halves. And there's our modified version. For the details, I sketched up the Markforged logo with the aid of a sketch picture and thin extruded it to be 60 thousandths wide and 40 thousandths tall. After adding some fillets to round off those corners, I used a move body command since I didn't merge it to the step, and then used a linear pattern to create the custom tread pattern. And on the side, I used an image to DXF converter to create the sketch of our logo and just extruded it. Let's throw these back into the slicer and get them ready for printing.